So now we want to find the limit of the function f of x equals the square root of 4 minus x squared as x approaches negative 2 from the right. And I don't know about you, but I don't know a whole lot about that graph. Like, I don't even know what it looks like. So I think it's a semicircle. Yeah? Maybe? Yeah. You're holding a graphing calculator, you want to check it out? And it does turn out to be a semicircle. Okay. So talk to me about it. What do you see? It's a semicircle.
Negative 2 is at 0.
All right. So you've got a spot at negative 2. You've got a spot at positive 2. Those are our x-intercepts, right? And then, how far up does it go?
2.
Up to 2? Yeah? All right. And guys, that's what semicircles look like, okay? If you have the square root of like a number minus x squared, those are going to be your semicircles. So some things, particularly square roots and piecewise functions, you may need to sketch a graph for to look at limits. The reason this one's interesting, it's not a piecewise function, but it's interesting because the domain is so limited. What's the domain of this function? Negative 2 to positive 2. So everywhere in between, if I'm tracing along, it's fine. But we need to talk about what's happening at the edges of the domain, because that can also cause problems with the limit. So the question we're being asked is to find the limit as x approaches negative 2 from the right of that function. So this is negative 2. Agree? So I'm talking about this point on the x-axis, right along here. I'm talking about coming in from this direction. Where is my pen going?
0.
0. So we say that the limit from the right as we approach negative 2 is 0. Okay, so now that we've established that, let's talk about the limit as we approach negative 2 from the left. As I try to come in from the left of this function, that's this area over here towards negative 2, what's the limit? Why not? Why? That's perfect, but why?
Because the line just stops.
There's nothing over there, right? There's nothing over there to approach from or to, right? So if you're in an area where the domain doesn't even exist at all, it's just an empty graph, you can't have a limit there. So what do we say about the plane limit as x approaches negative 2? Not from the left or right, but from both directions. It does not exist. In order for the limit, the actual limit to exist, you have to have the left and right coming to the exact same number. If one doesn't exist and the other does, you still can't say the limit exists there. So basically here, we want to find the limit of the greatest integer function as x approaches 0 from both the left and from the right. So we're interested in the 0 part there. I'll go ahead and help you guys graph this. I wish that it were a little bit bigger. Do you guys mind if I let each piece, every 3 pieces be 1?
Yeah, that's fine. Yes.
Y'all okay with that? So like, this is 1, this is 2, because we don't need a lot.
That's fine.
This is negative 1, this is negative 2.
Are you going to do the same for the y-axis?
Do you want me to?
Yeah.
What would you like me to count by on the y's? It doesn't matter.
Well, I don't know what numbers you're going to be dealing with.
Okay, well, let's
Just
count by,
X.
just to be different, let's count by 2s. Okay, so
Yeah.
let's do every 2 is 1. So this is 1, this is 2, this is 3, this is 4, this is negative 1, negative 2, negative 3. And I only did that because my boxes were so small.
Okay.
Okay, so let's talk about the greatest integer function. If I put, let's say, 0 in, what's my answer? 0. If I put 0.5 in, what's my answer?
0.
If I put 1 in, what's my answer?
1.
That's where it jumps, right? If I put in any number between 0 and 1, what does it do?
Goes to 0.
Rounds it down. So we agree that everything in here is 0, right? But the moment I hit 1, a circle opens up and the actual value hops up to 1. Okay?
So,
And then anything I plug in between 1 and 2, 1.1, what's the y value? 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. All of those have a y value of 1. We okay with that? Okay, let's go over and do some of these because it's the negatives that tend to trick you guys. Let's say I plug in negative 0.5.
Negative one.
No, it's 0.
Negative 0.
Negative 1 is bigger than
Zero.
Exactly.
Wait.
If I plug in negative
That's
0.5,
right.
It's 0.
what's the nearest integer less than negative 1 half?
Zero.
Negative 1, right? So he's down here at negative 1. Think of it on a number line. This is 0, this is negative 1. If I'm at negative 0.5 and I have to round down, then I have to go to this one.
That is crazy.
It is weird.
So then.
So everything between here and here is going to be negative 1.
But 0
But
shouldn't have
0's already been used up here, so we're going to put an open circle there. And then what goes over here? A closed or open?
Open.
close.
Close.
Right here?
Close.
If I actually take the greatest integer less than or equal to negative 1, what is it?
Close.
Open.
Well, it's closed, yeah.
Wow, the rest of them.
Okay, so let's pause for a second. So, we want to know what's the limit as x approaches 0 from the left, from the right, and we want to know the two-sided limit. So, let's take a look. What do you think the limit is as I approach 0 from the left? So here's my 0 mark. The y-axis is your 0 mark, right? So as I come in towards an x value of 0 from the left, what number am I approaching? Negative 1. All right, now let's talk about coming in from the right. In order to come towards 0 from the right, I have to be on this line tracing close to 0. As I get closer and closer, what y value am I coming towards?
0.
That's a 0 y value. So what can we say about the actual limit?
It does not exist.
Yeah, it only exists if they're going to the same place. So if you imagine tracing in from the left, from the right, there's a jump there. So it does not exist.